Yesterday I think I missed this part. Sorry. Okay, in this part, basically, okay, on the last class I just skip it, right? But if you look at it, you see that for this kind of shape, you will have the pressure force working on this direction, right? Normal, and shear force working on the tangential direction. If you take only the pressure force like this, you take the pressure force. This pressure force is not in x or y direction, but it has component in x and component in x and component in y. The component in y pushing the aircraft, the shape downwards. Okay. So this part, the y component, will contribute to the lift. See, this part will contribute to the lift. Okay, when we are talking about lift force, not necessarily it is lifting. Okay, because when we are talking about FL, sometimes it is down force. So it can be lift force or down force, but the direction is on the y direction. But some part of this pressure force is on the y direction, right? Because this component is like this. So it has component in y and it has component in x. The y component contributes to FL, the x component contributes to the drag force. In this case, the drag force is to the direction, to the negative x. Now, when we are talking about the shear stress over there, shear stress has two components also, because it is like that, slanted. So it has component in y direction and in in y and x direction. In y direction, it is giving negative lift, right? In the x direction, it gives positive drag. But if you look at this, then the question is, if this shape has the pressure working downstairs, downwards, why this kind of shape is used for the aircraft? Remember, we just taking the pressure or the force in this point, but we haven't do that for the whole shape. Okay, you see over there the pressure is providing down force, but over there the pressure is giving lift force. And as I said in the previous class, the velocity over there is higher, so the pressure is lower. That's why over there the pressure is higher, which means the force provided by the bottom pressure will be higher. Push them up. Okay, and if you look at this thing, you see the pressure providing drag to the front direction, right? To the left, which is the same with the movement of the airplane. So by right, this one will make it easier for the plane to move because we get the additional thrust. But if you look clearly, this thing will have bigger portion compared to that one. That's why at the end of the day, you'll find out that the drag is dominated by the friction and some ratio, of course, and the lift force will be dominated by pressure, pushing the aircraft upward. Okay, so that's what we have learned in the last class. Okay, we also know why the shape of the airplane wing is like this, right? And this is frontal area. So remember, the CD and CL is combination of both pressure and friction, right? When you have a flat plate like this, the pressure is marginal, it is minimum, because when we are talking about thin plate, the frontal area is very minimum, so you can neglect it, but the side area is bigger. Okay, so when the air is blowing from here, you will mostly get the friction drag. But when the air is blowing from the front side, you have full pressure drag, right? So you have friction and pressure. Usually it will not be splitted. Usually it will be given as a CD, a whole lump sum. Okay, but in certain conditions you need to split where you have only this CD of friction. Okay, so this is what I told you. When you have a flat plate, it's due to friction. When you have a normal plate like this, then you will have a pressure. Okay, and usually the more slender the body, the smaller the drag. That's why you see that nowadays cars getting thinner and thinner and thinner. Especially if you see supercar, nowadays it becomes like that. Right? And this one is a flow spiration. What is the important point of this flow spiration? You will find that the earlier the spiration, the bigger the weight, the bigger the drag ratio. Okay? So this one will be used later. And this is how we measure the drag coefficient of a car or airplane or whatsoever. Okay? This is just a simple thing. But if you look at the one down here or over there, it is loaded in the load cell. Right? You know the load cell? When you do the wind tunnel test, any one of you have done it in this room? Wind tunnel test? Not yet? In the wind tunnel test, you have the load cell. This load cell is attached to the specimen. If, let's say, your specimen is aircraft, okay, then it will measure the drag and the lift. Okay, it will measure the lift as well as the drag. This thing is load cell, very expensive. Okay, but if you just want to calculate the drag force, you can do simple. Okay, buy a big fan, very big one. Okay, because if you want to put the real car, it has to be a very big fan. Make a big tunnel like this, right? Put the fan over there. Maybe the fan is not one, but several. Ensure the flow is homogeneous, uniform. Whatever you want. If you want to have it 95 km per hour, which means the velocity has to be 26.39 meter per second. Okay, you can imagine that. And then hook your car at the chassis, not on the bumper, but on the chassis where the engine is mounted. Hook there with a strong winch or string. Then you buy a big weighing machine. You know, the one that, the small one is like the one that you use to measure the luggage, right? I do not know whether you have one. If you want to measure the baby, you put it there, and then something like in your Hawaiian, you put it there, then the baby, you can measure the weight of the baby, something like that. Okay, but this one is the big one. You put it there, and then you start to blow the air. Okay, once the air is blowing, due to the friction, you will start to push the car until equilibrium is achieved. When the equilibrium is achieved, you can see what is the force needed to push that car to that position. Right? Once you have that, you know that that one is your FD. You know your FD, you know your velocity because this one is set. You know the condition of your air, like in this room, it is about 25 degrees, 1 atm. Then you can measure your density and the frontal area. This one is tricky. Basically, we will just take a rough estimation of our car, right? Because your car has a lot of those complex shape will be there. Right? The tire will, especially if your left and right tire is not the same. Right? You use the spare tire, which is now space saver tire, smaller, but you don't want to change it. It looks cool, so you put it there, and then you need to calculate all those things. Okay, but as long as you get the area, you you can calculate what is the drag. Once you get this drag, you don't need to do any other calculation, right? So if you want to measure the force for different conditions, you just take the drag coefficient, and accordingly you use what is the velocity that you want to use to measure the drag force. Okay, clear. So that's why it is very important, because once you get the CD, you can use it for any condition. For any condition you can use the CD. Any velocity, any density, and so on. Okay, here, but this one is only for air. Will not work. Let's say, will it work for if I put my car in the water? Will it work if I immerse or I? Okay, if you watch Minion movies, the agent wow, yeah, drive the car, then plunge to the water, right, and then the car becomes a submarine and moving. In that case, the CD in the air and the CD in the water may be different. Maybe. It depends on the Renault number, but the Renault number is different with the viscosity. Right? So in that case, the CD may be different. You remember when you are having this dimensional and modeling similitude? Yes. Right? If you want to get the same CD, you need to have the same Renault number. Okay? So since the Renault number for water and air is different, the CD maybe it can be the same. Okay, any questions so far until this point?